Hi there, you're welcome to our first class in mathematics. Today we'll be looking at numbers, okay? Counting and identifying numbers from 1 to 100. Actually, 1 to 100 is for those in grade 1. For the students in grade 2, we'll be extending the numbers to 200. We'll be doing 1 to 200. But the most important thing here is understanding how numbers are formed, understanding how numbers increase from one level to another, understanding the transition points of numbers. Once the pattern is understood, once you're able to get a hold of the pattern, you'll be able to build numbers to thousands. At least at your level, you should be able to build up to thousands. But we are not going up to thousands. We are just going up to 100. And for those in grade 2, we are going up to 200. So please pay attention, okay, while we walk through this to see how numbers, first identifying them and then being able to count them, okay? Yeah, why I say understanding how numbers are formed, if you know what numbers come together to form a certain number, it will be easier for you to be able to name. When you name, you can count it. And when you count it, you should also be able to identify that number. Okay, that's why it's important to know how they are formed first of all. So for a start, we're going to look at the basic digits that are used in forming all the numbers in existence. The basic digits that are used to form all the numbers in existence in the Roman numerals. These numbers that we see here, they are referred to as the Arabic numerals. They are referred to as the Arabic numerals. We'll come to Roman numerals later on in our lessons, okay? But for now, we're dealing with the numbers we are familiar with, which we use in our everyday life, and that is the Arabic. This is Arabic numerals, okay? This is the Arabic numerals. Now I'd like to mention that these numbers, these single digit numbers from 1 to 9, we see from 1 to 9 there, but there's actually a 0, okay, before 1. I deliberately omitted the 0. I left it out deliberately because it will offset the pattern we are trying to build here. If we put 0 at the beginning here, it's going to offset the pattern that we're trying to build, okay? So we put 0 here, but mind you, take note that 0 is before 1, and then up to 9, you have the single digit numbers that are combined differently. They are combined in different ways to form all the numbers in the Arabic numerals. Okay, so the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are the digit numbers that are combined to form all the numbers in existence in Arabic numerals. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And you see that these are the only numbers that are single digit numbers. And among these single digit numbers, 9 is the highest single digit number. 9 is the digit that has the highest value among those single digit numbers. And also 9 is the point of transition. From 9, you always move to a next level. When you are counting, when you are moving one step after the other, after 9, there is always a new level that you get to. Okay, so first please take note of these single digit numbers, and we are going to name them. We're going to try and count them. Then we'll come to see how they build how they progress, how they move from one level to another, so that we'll be able to not only form numbers, we'll be able to identify them, and we'll be able to count these numbers. Okay, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if you look at 10, you will see that 10 is a 2-digit number. That means it has 2 digits joined together. 1 is there and 0 is there. 1 and 0, these 2-digit numbers combine to form 10. 2 and 0 combine to form 20. 1 and 4 combine to form 14. 1 and 7 combine to form 17. 3 and 6 combine to form 36. So you see what I was trying to explain by saying that all the numbers that you see that are in existence in the Arabic numerals, they are formed by combining, by joining these single-digit numbers in different ways. By joining these single-digit numbers in different ways, you form every other number. Okay, so 10 is a transition point. 9 and 10. From 9, you are transitioning to a 2-digit number. You are moving on to a 2-digit number. Now I will show us just a little demonstration. I will show us something that will help us. So for instance, if they say 1 simply is unit. When you hear unit, it means single, just what it is. So 1 as a unit is just one item, only one. And 2 as a unit or under unit is just 2. Okay? So these are single unit numbers. They are single unit numbers. But when you get to 10, you find 2-digit numbers. They are no longer single unit numbers. They have crossed from being unit to the next value that you have in numbers, which is tens. Unit is for every number that is less than 10. But from 10, we cross over to a higher level, and that's the level of tens. Now, how do we form our tens? When you have 9 units, you have like these 9 building blocks. Now these are 9. And like I said, 9 is the highest single digit number in existence. That means under unit, 9 is the largest number you can write under unit. Unit is for single digits. 9 is the largest number you can write there as a single digit. If you add one more digit to this 9, it can no longer be contained. It can't stay in under the unit section again, because it has become a 2-digit number, and it has become a number that is capable of staying in the tens section. So what do? And once it becomes tens, you cannot leave it loose like this. You can't leave the numbers loose like this. You can't leave them singly like this, floating around. No. What you do is, once you get 10 of these, you stack them up together like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you stack them up together to form one column of 10. This is 110. And if everything has been stuck together to get this 110, that means there is nothing left under unit. So under unit, you will have what? 0. And under tens, you will have 1. So that's how you get your 10. Because the whole 10 units have been stuck together to form 110. Nothing is left under unit anymore, because everything has been packed up here. So in tens, you have 1, just one column of 10, and in units, you have nothing. So it is 1 and 0, 10. 0 units, 110. Now, if you add one more unit to this 10, what do you have? This is one column of 10, and then this 1 unit will come under the unit section. So you have 110, 1 unit, and that number is 11. 11. Now let's add 5 units to our 10. You have a column of 10 already, you add 5 units. You have one column of 10, still 110. And how many units here? 1, 2, 3, 4, 5. You have 5 units. And that number is 15. 110, 5 units is 15. Now let's go up to 9 units. Remember, 9 is the biggest number that you can have under the unit section. So here you will have 110, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units. 110, 9 units. That number is 19. Now let's add one more unit to 19. Remember, we said that 9 is a point of transition, point of change. Remember, 9 is the biggest number, biggest single digit number that can be under unit. Now we have an extra unit added to 9. Can we write the answer we get in here under unit? Can unit handle that number? No. 9 plus one more digit gives you 10, and 10 is a 2-digit number. 10 is a 2-digit number. So what happens? The 0, here is your tens, here is your unit. You have your 0 on the unit and you have your 1 on the tens. But remember, previously we had 110 and 9 units, isn't it? And now the one more unit we brought has been added to 9 to make 9 10. Now this 9 has become 10, okay? But we know we can't write 10 under unit. So what do? We put the 0 under the unit, and the 1 comes to tens. The 1 comes to the section of tens. So now you have 2 ones, 2 columns of 1s in the tens section, okay? You stack them together again. You have 2 columns of 10. So here you will now have 20, which is 2 tens and 0 units. That is your number 20. 2 tens and 0 units. Now let's see how we count these numbers from 1 to 20. Then once we get to 20, I'm going to show us how we count in the tens. Because once you are able to know the names of the single digits first, and you are able to count from 1 to 20, then continuing down to 100 becomes very easy. It becomes very easy because at that point, all you now need to know is the numbers that are multiples of 10, all the numbers that end in 0 from 10 to 100. Once you know those, every other thing is simply naming or calling those multiples of 10 and adding the digits. All these single digits, whatever digit is with it, you call the name. You call the level of the multiple of 10 and you call the unit that is attached to it. It's as simple as that. You call the level of the multiple of 10 and the digit that is attached, the unit that is attached, whatever that number is. So let's start from 1 or 0. Here you have 0, then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, you can say that after me, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the next number after 10, which we have seen how it works, is 11. 110, 1 unit. 110, 1 unit, that's 11. 11. 110, 2 units, 12. 110, 3 units, 13. 110, 4 units, 14. 110, 5 units, 15. 110, 6 units, 16. 110, 7 units, 17. 110, 8 units, 18. 110, 9 units, 19. And then we come to a transition point again. If you add 1 more unit to 19, 9, the number that forms can stay under unit. It's a 2-digit number, which is 10. So the 0 stays under unit, and you transfer the 1 to the tens section. So 1 more tens added to the 1 already here will give you 2. So you have 2 tens, 0 units, and that number is 20. 2 tens, 0 units. Remember, whenever you get to 9, you are about to step to the next level. You are about to go a step higher. Always remember, once you get to 9, any addition of an extra unit takes you to the next level. Okay, so we have 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So now we're going to look at, we quickly look at the multiples of 10. That is the numbers that form at every transition point, the new numbers. Okay, we look at them from 10 to 100. These are called the multiples of 10. They are called the multiples of 10 because they can be divided by 10 without a remainder. Okay, so we quickly look at this and then see how the other numbers are formed. Because by knowing how they are formed, you'll be able to identify them and also count them. So the first one here is 10. 10. The next one is 20. 20. 2 and 0. 2 tens, 0 units, 20. 3 tens, 0 unit is 30. 4 tens, 0 unit is 40. 5 tens, 0 unit is 50. 6 tens, 0 unit is 60. 7 tens, 0 unit is 70. 8 tens, 0 unit is 80. 9 tens and 0 units is 90. And 10 tens with 0 units is 100. 10 tens with 0 units is 100. That is why you have 1 0, which is the 10, and then the 0 units. 10 tens and 0 units. So let's go over that again. We have 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay, so we have learned how to count from 1 to 20. Now from 21, it becomes so easy. Okay, that's why we needed to first learn the names of the multiples of 10, from 10 to 100. Because from 20, all you just do is call the name of the multiple of 10 that you have reached or arrived at, and you add the name of the units with it, whatever the a single digit number is that is added to it. Whatever the number is that is in the unit position, you simply name it after the number in the multiples of 10. For instance, 20 is a multiple of 10, so after 20 you simply have 21. Remember, this is 1. And after 1, the next number is 2, so you have after 21 is 22. 20 and 2. That 20 is simply 2 tens. 2 tens, 2 units, 22. 2 tens, 3 units is 23. 24, 25, 26, 27, 28, 29, and then you get to a next level of the multiples of 10, which is 30. So once you've reached 30, you just start all over again, adding that name, the names of the single digit numbers to 30. It's as simple as that. Now the next number after 30 will be 31. You look at it, it's under 1. 32, 30 and 2, 33, 30 and 3, which is 3 tens and 3, 34, 30 and 4, 35, 30 and 5, 36, 37, 38, 39. Again, we get to a point where we need to step up to the next level in our multiples of 10. And the next one is 40. 40 after 39 is 40. So again, you start just like we have been doing it all the way from 20. It continues, it's the same pattern. So from 40, the next number is 40 and 1, which is 41. 42, 43, 44, 45, 46, 47, 48, 49, and the next multiple of 10 is 50. 50. So, like we did in the previous numbers, we start all over again with the single digit numbers being added to 50. So you have 50 and 1, which is 51. 50 and 2, 52. 50 and 3, 53. 54, 55, 56, 57, 58, 59, 60. We start again, or we continue using the same pattern we have been using. 60 and 1, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70. 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. 100. So now let's look at the pattern. You have the single digit numbers all here from 0 to 9, and you have the multiples of 10 from 10 to 100. And what do you do in building your numbers? You simply add the units to the tens and you name them accordingly. For example, the tens we have here is 20. So if you're going to add an extra unit to 20, that is 1 unit, it will be 20 and 1, which is 21. If you add 2 units to 20, it will be 20 and 2 units. That is 2 tens and 2 units, 20 and 2, that is 22. If you add 3 units, 3 single more units, just taking it one step higher, okay? If you add 3 units, it will be 20 and 3, which is 23. If you add 4 units, 20 and 4, 24. It goes on till you get to the next multiple of 10, which is 30. So 1 more unit again to 30, it gives you 31. 2 units, 32. 3 units, 33. 4 units, 34. 5 units, 35. It keeps going till you get to 40. It starts all over again. 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Okay, so just know that you're going to be repeating the single digit numbers as you name them. That means you really need to understand the multiples of 10 so that you'll be able to name them alongside with the single digit numbers that are attached to them when you are counting from 1 to 100. So once again, let's quickly run over the multiples of 10. You have 10, you have 20, you have 30, you have 40, you have 50, you have 60, you have 70, you have 80, you have 90, and you have 100. Now let's look at the pattern here. Just note, all the multiples of 10, they end with 0. And what else do you notice? The first multiple of 10 starts with 1, which is 110 and 0 units. The next one is 2, followed by 3, 4. If you look at it, all the units that are growing, increasing here in the power of 10, they are all the same as the single digit numbers. The only difference is that these ones have zeros added to them. And these zeros indicate that these numbers are they don't have values in the unit part, they are all in the tens part. A column of 10. Remember we did the example that once your units get up to 9, if you add one extra one, they can't stay loose anymore. They will be stacked up to form a column of 10. So all these numbers are columns that are formed here. This is just one column of 10 with 0 units, 2 columns with 0 unit, 3 columns with 0 unit, 4 columns with they are tens. But the important thing I want you to note here is how the numbers also start from 1 up to 9 and then 10. 1 and 0, 2 and 0, 3 and 0, 4 and 0, 5 and 0, 6 and 0, 7 and 0, 8 and 0, 9 and 0, 10 and 0. So those are the multiples of 10. Once you get acquainted with the names, you won't find it difficult anymore to count your numbers from 1 to 100. Okay, so once again, let's remind ourselves of these ones from 1 to 20 because those are a bit different. You know, from 11 to 20 is not like you have from 21 up to 100, the way the names are called. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so those are the numbers from 1 to 100. Now for our grade 2 students, yours is actually supposed to extend up to 200. Now I'm just going to show you the basic thing. It's the same thing. It's the same way it is formed. Remember, your 100 is 10 tens and 1 unit, right? 10 tens and 1 unit. Sorry, your 100 is 10 tens and 0 units. Pardon me. Tens unit, okay. 0 unit, 10 tens. Now, who can tell me what is wrong with these 10 tens I wrote? Yeah, 2 digits cannot be placed under these tens. It has to be 1 digit at a time. So just like a unit section can hold only 1 digit, this tens section can also hold 1 digit. So there is a spillover. So what happens to that one that can't stay under tens? It comes under 100. Remember, here we have how many digits? We have 3 digits numbers that make 100, and that's where this third section comes in. This H here stands for 100. The U here stands for units or ones. This unit or ones. The T stands for tens, and the H stands for 100. So 100 is 0 units, 0 tens, 100. Now your 100 is a stack of 10 tens. Remember, your 10 is a column of 10 units. Now when you have 10 of the columns stacked together, it gives you 100. Yeah, I wish. So the last part we're going to look at today is odd and even numbers. Okay, even and odd numbers. What are even numbers? They are numbers that form pairs when they are shared into 2 parts. Numbers that form pairs when they are shared into two parts. What does pair mean? Pair means two that are the same. Two parts, two things that are exactly the same. Like you can say you have a pair of feet. Because you have feet, the left is exactly the same as your right. I have a pair of shoes. The left leg is exactly like the right. So when you say pairs, pairs always refers to two things that are exactly the same. So when you share even numbers into two parts, you always come up with two equal parts. But it is not the same thing with odd numbers. Odd numbers do not form pairs, but they always have remainders. When you try to share odd numbers into two parts, you always end up with something left that cannot be shared. So there is always a remainder. So those numbers are called odd numbers. Even numbers form pairs, odd numbers do not, but always have remainder. Now this chart, I left it so that we could use it to explore this concept of even and odd numbers. So let's quickly look at the pattern that has been formed, and that's the main reason I left this chart on. If you look at the column of 1, all the numbers under this 1, you see the numbers in this column, they all end in 1. All the numbers in this column end in 1. All the numbers in this column of 2, they end in 2. All the numbers in this column of 3, they end in 3. All the numbers in this column of 4, they end in 4. All the way down, all the numbers in the column of 10 end in 0. Now, here is what I will quickly point out. We're not going to spend too much time on this. It's actually going to give you something to work on, okay? And you're going to have fun doing it. Now, look at it. If you have one orange, I want to get this off so that we have a little space to work on. You can always go back to the video when you get to this point. You pause it if you need to write something down. Okay, so let's say we have one orange and we need to share that orange for these two fellows. One person will get one, the other person will be left with nothing. We can't get two pairs from this. We can't get two equal parts of the orange of the orange for them. Yeah, someone will say, yeah, but you can share the orange into halves. You can share the orange into two equal halves. Yes, you're smart and I totally agree with you. But remember that in this, in what we are exploring right now, we are not looking at fractions. We are not looking at anything that is part of a whole. We are looking at whole numbers. We're not looking at fractions. We're not looking at decimals. We are looking at whole numbers, okay? So 1 is an odd number because there will always be something that is off. You can't get two equal parts when you share an odd number into two parts. So 1 is an example of an odd number. And if you check 2, let's go to 2. Let's check 2 before I go to something else. Let's share these two oranges for these two fellas. So this first guy takes 1, the second one takes 1. Each of them has something. And do you think they have the same quantity of oranges? They do. The first person here has 1 orange, and the other guy also has 1 orange. So you see there is a pair here. Remember we said pair means two things that are exactly the same. So he gets 1 orange, the other person gets 1 orange. So 2, for instance, is an even number. 2 is an even number. Let's try to work with 3 oranges. I hope we can see the board. So let's try to work with 3 oranges. We have seen that we can't share 1 orange, okay, among 2 people. Now let's look at 3 oranges. We have 1, 2, 3. We're still sharing them for these 2 stick men. Okay, sharing them for these 2 stick men. So the first guy takes 1 orange, the second guy takes 1 orange, and there's 1 more orange left. And like we mentioned earlier, we can't share that one between these 2 people because that's going to lead us to fraction. It's going to lead us to fraction, and we are not dealing with fraction. So here again we find that we have something that is left, a remainder. We have a remainder. And remember, we said that odd numbers are those numbers that when you share them into two parts, there is always what? A remainder. So that means that 3 is an odd number. I hope we're following. We have agreed that 1 is an odd number, 3 is an odd number, and then we've been able to explain or look into 2 as an even number. Okay, so we used 2 oranges, we shared it among these 2 people, and we found out that they both got equal amount. Now let's look at the next number, which is 4, and let's see, still 4 oranges for these 2 stick men. Let's see how it goes with them. So this one gets 1 orange, this one gets 1 orange. This one gets a second orange, this one gets a second orange. Everything is gone. So we find out that the 2 stick men, each of them has 2 oranges. Each stick man has 2 oranges. So here again we see a picture of a pair. A pair, remember, is 2 things that are exactly the same. So that means that 4, just like 2, is an even number. 4, just like 2, is an even number. Are we seeing a pattern building already? Can we see a pattern is building? Now let's check the last set of numbers, 5 and 6, and let's see. So let's look at 5. Again, we have 5 oranges, and we need to share them among 2 people. So you have 5 and you have the 2 stick men as usual. So the first guy gets 1, the second one gets 1. The first guy gets 2, the second guy gets 2. And then we have 1 left, and we can give that 1 to both of them. Remember, we can't split that 1. We can share it into halves. It's not possible when we're dealing with whole numbers. So here again, we find a remainder. So that means 5 is an odd number. And the last number we're looking at is 6. So here we're going to share 6 oranges among these 2 guys. 1, 2, 3, 4, 5, and 6. So we have 2 stick men as usual. So the first guy gets 1, the second gets 1. The first guy gets 1, the second gets 1. The first guy gets 1, the second gets 1. Everything is gone. Now let's see, does each of them have the same amount of oranges as the other? 1, 2, 3, the first guy, the second guy, 1, 2, 3. Wow, they have exactly the same thing. So here again we see pair. You know, remember we said the pair is the same, 2 parts being the same. We have the 2 guys having exactly the same number of oranges. So which means that 6 is an even number. So here we have been able to show that 1 is odd. Yeah, we start with 1. 3 is odd, and 5 is odd. Have we seen the pattern already? Now let's go to our chart. Okay, let's come back to our chart. 1, we have established that 1 is an odd number, 2 is even. I'll just write on the, okay? So we use O to represent odd and E to represent even. So 1 is odd, we have seen how it is. 2 is even, we have seen how that works. 3 is odd. 4 is even. 5 is odd. 6 is even. So you see the way it's going. Every consecutive number is just like the other one. So 1 is 0, 2 is even. 3 is 0, 4 is even. 5 is 0, 6 is even. 7 is what? Odd. 8 is what? Even. Because it's a pattern. 9 is what? Odd. And 10 is even. Okay, so now for 10, mind you, is a number. 10 represents all the numbers that end in 0. Okay, 10 represents all the numbers that end in 0. We're going to get to that. Okay, so what I want us to see now is the pattern. 1 odd, 1 even. 1 odd, 1 even. 1 odd. You see the way it goes? So all the numbers under this column of 1, they are odd numbers. 11 is an odd number. 21 is an odd number. 31 is an odd number. 41 is an odd number. 51, 61, 71, 81, they are all odd numbers. Now we found that 2 is an even number. That means all the numbers in this column of 2, they are even numbers. 2 is even, 12 is even, 22 is even, 32 is even, 42 is even. So every number that ends in 2 is an even number. Now we go to the next one, 3. We found out that 3 is an odd number. And that follows for every number in this column. Every number that ends in 3 is an odd number. 4 is an even number, and that goes for every number in this column. 4 is even, and that means all the numbers that end with 4, they are even numbers. Just like that. 5 is odd. All the numbers that end in 5 are odd numbers. 6 is even. All the numbers that end in 6 are even. 7 is odd. All the numbers that end in 7, they are odd. 8 is even. All the numbers that end in 8, they are even. 9 is odd. All the numbers that end in 9, they are odd. And 10 is even, or 0. Okay, numbers that end with 0, they are even. So all the numbers you're seeing here in the column of 10, they are even numbers. Okay, so please, I will really advise that you practice this. Okay, keep going over, keep practicing. You need to keep practicing. You don't just watch this once and then you feel you've understood everything. You need to keep practicing it and keep revising. Okay, if you have noted down some important things from this video, you go back and review it. Go back and go through it again so that you have a good understanding of the concept. Okay, so here's what we're going to call it a day. For those of you in grade 2, please, you need to build this chart up to 200. This chart here stops at 100. You need to use the pattern we explored and complete this chart up to 200. Okay, we hope to see you guys next week. If this video is helpful to you, please help us share the link, and we'll see you next week for a continuation of exploration of numbers. Stay blessed and stay safe.